Hey, pre-calculus, sorry that I'm not here on Friday, but I know you didn't want to see my ugly face anyway, so now I just made a video and we're going to recap right triangle trigonometry. You did this in geometry, and you may have done a little bit in algebra 2, and we're back. So just so you know why we have something called right triangle trigonometry, or what we need it for, if I draw a triangle such as this, and I say to you, please find the value of x, you know this is a 30, 60, 90, and we've learned that the short leg is half the hypotenuse. X is 6, and that's very easy. But if I take a triangle and I make it look kind of the same, but instead of 30 degrees, I make it 32 degrees, now all of a sudden we really can't do this. This is not a special triangle. We can estimate x to be probably not too far from 6 in this case, but it's definitely not 6. So we need some way to figure out how to find missing sides and angles when we're dealing with triangles that are not special. So if you recall, we had a mnemonic to help us remember the trig functions and how to use them. So we have SOHCAHTOA, if you remember. That means that the sine of an angle is the opposite over hypotenuse ratio. The cosine of an angle is the adjacent over the hypotenuse of the angle, of the triangle, and the tangent is the opposite side over the adjacent side. To write it in a different way, the sine of some angle is always equal to the opposite side over the hypotenuse. The cosine of an angle, oops, this is kind of in my way here. Cosine of an angle can be defined as the adjacent over the hypotenuse, and the tangent of an angle is equal to the opposite over the adjacent. Okay, so you want to make sure you have these three ratios committed to memory if you don't already. So how do we use them? Well, let's come back up to here. In this triangle here, 12 is clearly the hypotenuse of the triangle, so I'm going to put an H. Now the side over here, well, that's not next to 32. Next to would be right here. So this is the adjacent. So x is the opposite. So notice how, based on this angle 32, we don't care about the adjacent. It's not given and it's not being asked for. So if I want to find the opposite, I need to find what trig ratio uses opposite and hypotenuse, and that would be sine. So that means the sine of an angle, the sine of 32, is equal to the opposite over the hypotenuse. Now I'm going to cross multiply to get x alone. And now I'm going to run to my calculator. Okay, now make sure your calculator is in degree mode. There's some element of degree. We'll talk more about how to check to see if you're in the right mode in a second. But to find x, I can just do 12 times sine 32. Oopsie, that's not 32, you big silly. Now I didn't tell you how to round, but let's round to the nearest hundredth. That would be 6.36. By the way, if I said round to the nearest thousandth, no, let's round to the nearest 10,000th. 10,000th would be 4 decimal places later. You have to put that 0 there. So if I did say 10,000th, you would do 3, 5, 9, and if you don't put the O, people think you only rounded to the thousandth. So you do have to put the O if the rounding includes a 0. All right, so that's basic trig. Let's do another one. Okay, again, this is right triangle trigonometry, so it better be a right triangle, which this is. It's not special, it's not a 30, 60, 90, so we're gonna need trig. The hypotenuse is opposite the right angle, so there's your hypotenuse. Here's our adjacent. Notice how the opposite of 17 is useless. So we're gonna use A and H. A and H is the cosine ratio. So cosine of 17 is equal to the adjacent over the hypotenuse. Okay, I'm gonna cross multiply. I'm going to now divide by cosine 17. And now I'm going to type that into my calculator. Make sure you know how to get your radical symbol gotten to. So 2 square root of 6. Notice how my square root button automatically put parentheses, so I better close it to show that the square root is done. Now I'm going to divide by cosine 17. I don't think I need parentheses for that because cosine 17 is its own unit. Close the parentheses. 5.1, however I decide to round. Make sure your answer makes sense, right? I mean, if x was like 5 billion, we would know that would not be right. But 5.1 is a little bit bigger than 2 root 6, so that's good. I think it is anyway. I can always check with my calculator. Okay, so that's the basics of trig. You can also go backwards. So you can find an angle using trig, in case you forgot. So in this case, what if I want to find this angle up here? And this is a 2 and this is a 3. Okay? I can Pythagorean theorem to find the side, but how do I find the angle? I can still use trig. We have an opposite and we have an adjacent to x. Notice I don't care about the hypotenuse in this case. So who uses OA? Tangent. So the tangent of the angle is opposite over adjacent. Now you can't type this in and you can't divide by tangent, but what I can do is inverse. You may have done inverse functions in algebra 2. Inverse means switch. So now inverse tan 3/2 equals x. So up here, sine of 32 says, hey calculator, what is the opposite hypotenuse ratio if we have 32 degrees? This is saying, hey calculator, what angle has this as an opposite adjacent ratio? Okay, so here's my tangent button. Tangent -1 or tan inverse is up there. So I can do inverse tangent, and I want to do 3/2. And it gives me an angle, which I can round to 56.3, or however you're supposed to round it. All right. Now, I want to come back up to this question here. What if, let's say you didn't want to use this 32. What if you finished the 180 triangle and you called this angle 58? Well, what if 58 were my angle? Now all of a sudden, x is not opposite, x is adjacent. So now instead of using sine, I would use cosine. Is that allowed? Can I do cosine of 58 equals the adjacent over hypotenuse? If I do 12 times cosine 58, will I get the same thing? 6.35, there it is. It's the exact same thing. So that's interesting. So the sine of this angle and the cosine of this angle are the same. The opposite hypotenuse to that is the same as the adjacent hypotenuse to that. In fact, that's always the case. The sine of theta and the cosine of the complement of theta, it'll always be the complement. These two angles add to 90 because they have to. We have 90 here. These need to make the 180. So the sine and the cosine of two complementary angles will be the same. That means that sine and cosine are co-functions. Co-functions means that the sine of one angle and the cosine of its complement will be the same. That's why it's sine and cosine. The co stands for co-function. All right, so that's kind of nice to know for whatever reason. Now, we can do things like we can find trig of special angles pretty quickly. So suppose I say to you, what is the tangent of a 45-degree angle? No calculators allowed. Well, if we have a 45-degree angle in a right triangle, that means it's a 45, 45, 90. That means these sides, whatever they are, they have to match. This is x root 2. Now, 45, tangent is opposite over adjacent. Well, what's x over x? 1. Tangent of 45 is 1. This is a good way to check that your calculator's in degree mode. Tangent of 45 is 1. Sometimes your calculator might be in a different mode. The DRG on this one, you can choose radians or gradians. I don't even know what those are. So now if I'm in the wrong mode and I do tan 45, I'm not getting 1. Something's wrong. So I can go back up and change it to degrees. Oops, and hit a wrong button. And then you can get the tan of 45. And you can do this with other specials. What if I say to you, what's the sine of 60? Well, I can draw the triangle. There's 60. I can make up my own sides. Maybe I don't want to have x's. This is the short leg. I'm going to call it 1. Double it to get the hypotenuse. Short leg times root 3 to get the long leg. And now sine is opposite over hypotenuse. Opposite over hypotenuse, the square root of 3 over 2. Now if I do sine of 60 here, it's giving me the decimal equivalent, 0.866. But if I did the square root of 3 over 2, I get 0.866. So I know I'm right. All right, a couple more things before we call it a day. More rectangle trigonometry. If I say to you, if tangent of theta is equal to root 2 over 4, what if I ask you to find the cosine of theta? and no calculators on this. Well, this is saying that there is some opposite adjacent scenario in a right triangle. Let's set up the triangle. Here's our theta. Root 2 is opposite, 4 is adjacent. Now to find the cosine of theta, I need adjacent over hypotenuse. So I need to find this hypotenuse. How would I find that? I can use Pythagorean theorem. So we have 3 root 2, the square root of 18, but 3 root 2. So now that h is 3 root 2, I can say that the cosine of that theta is the adjacent over the hypotenuse. I can rationalize. And yes, I can reduce that. All right. One more type of question I'd like to show at you, and then this video will be done. I want to refresh angles of depression and elevation. Now, you may have done these in geometry, and they may have been quite difficult in geometry. They're not going to be super difficult here. I just don't want you to forget this skill. This is basically applications to trig. Okay, so when you're standing somewhere, and there's some object in front of you that is hard to measure directly, you have your horizontal line of sight, and you can either look up, and I'll call that x, or you can look down from your horizontal line of sight, and we call that y. Now we have right triangles everywhere. X is an angle of elevation because we're looking above our horizontal line of sight. Y, the angle below, is known as an angle of depression because we're looking below. And we can indirectly find the height of something that's really hard to measure directly if we can measure these angles, and there are machines that do it, and if we know our height and we know how far away we stand. So let's do one example. I want you to imagine that we have an airplane. Airplane's altitude is easily measured. You might say that we're at 20,000 feet. And it sees the runway at a 23-degree angle of depression. Now, how far is the airplane from the runway? Runway. How far is the plane from the runway? It wants to see if it has enough gas. So here's the plane. I'm not going to make it a very complicated drawing. Here's the ground, and here's the runway. So this is basically what we're being asked to measure, how far away they are. Now I have the height of the airplane, 20,000. Right angle. I need to find this. I need an angle, 23. Now you're going to be tempted to put the 23 here, but that's not correct. An angle of depression, look up here, is based on the horizontal line of sight. It's not based on a vertical. So we have to draw the airplane's horizontal line of sight. This is the 23. Now that 23 is not inside the triangle we want to play with, but if you remember from geometry, this is an alternate interior situation, so we can put the 23 there. So now we have a right triangle. Based on the 23, we have opposite and we have hypotenuse. We can do the sine ratio. The sine of 23 is 20,000 over x, cross multiply, divide by sine 23. I did 2 steps in one, don't judge. Now we're going to do 20,000 divided by sine 23, and I get, looks like, about 51,186 feet. And I can then do the math to see if I have enough gas. Okay, so this was the recap of trigonometry in a nutshell. Please work on page 3 of your packet, and that will be due next class period. Please note that if you look at page 3, there are a couple of problems that repeat a function. So it might say like find sine theta, and you're like, what? I don't know why it did that. It's a formatting thing. So if you ever see a double function like this, one of them should be erased. That is all. Thank you for listening.